everybody, my name's Miss Margie and I'm from the Northwoods Children's Museum here in the beautiful Northwoods, Eagle River, Wisconsin. Today we have some really simple materials that we can use, hopefully that you have right in your own house, to do some inexpensive science experiments. So, if we're gonna be a scientist, we might as well play the part, and the more the better. You don't have to have any of these supplies, however, but when you do, it just makes it a little bit more fun. Eye protection, and the white lab coat. Now we're gonna play scientist. So for our science experiment, we are going to be measuring. So what I did ahead of time is I grabbed some baking soda. This is a huge bag, but lots of times baking soda comes in a very small box for about $1. So I poured the baking soda in this container and I have a measuring spoon. This is a half a tablespoon measuring spoon. Then we have this huge gallon of just plain white vinegar. And this white vinegar is about $3.75 for the whole gallon. So you could do this whole experiment today for under $5. What we did ahead of time is we poured the vinegar into these smaller bottles, which would be easier for children's fingers to use for pouring and measuring. So what we're going to do first is we put just these simple clear cups. Clear is more fun because then you can see everything, what's happening. But it's empty right now and we are going to measure. So we're going to pour 1/4 cup white vinegar into the cups. We have a lot of cups here. I might spill, children might spill, and that's okay because this is all part of how we learn. So what we're going to do here is we're going to do 4 different experiments using the same materials but different amounts. So the vinegar is going to be the same in all 4 experiments. We have these cool little black trays too, but you don't need anything special. You could use a cookie pan, you could do this over the sink, or even in your bathtub. You don't even need to do it 4 separate times. So the name of this experiment is called Dancing Raisins. It's kind of silly because raisins don't really dance. But what we're using today is we are going to use our minds to creatively think and problem solve, and we might even be a little bit silly about it. So right now, these raisins were cut up really small. And if we want the raisins to dance, we have to do something. So my first thought is I'm gonna have to guess. Now, scientists guess all the time. It's called a hypothesis. A hypothesis really is just a fancy name for maybe a theory or a guess. So my guess is if I put these raisins in the vinegar, they're gonna dance around. Now, dancing raisins, they might not dance like we do, but they could dance by going down to the bottom and then coming back up. Down to the bottom and coming back up. So ready? Let's count to 3. 1, 2, 3. They sank. They definitely are not dancing. They're not doing anything very special either. So I'm gonna try and come up with a couple different guesses. One guess would be they're not dancing because maybe they need a little bit of wind. So I'm gonna blow on them to see if they can dance. They're moving a little bit, but they're not coming all the way back to the top. So another thing we could do, real gentle, I'm actually gonna shake this tray to see if that will help. It's not. So if I need to come up with something else, why would a raisin dance? Why would a raisin dance? Music! Oh, okay. All right. La 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 la. Now you can sing to your raisins any song you want. You know, because not everybody likes the same kind of music. So I'm thinking Happy birthday. That's kind of a good song. All right, come on, Raisins, here we go. Happy birthday to you. Happy birthday to you. Happy birthday, dear Raisins. Happy birthday to you. Nothing. Didn't work at all. So I'm gonna have to try something else. But I have something really cool that I think might work. This is baking soda. And remember that measuring spoon I have? So I'm gonna measure this and put it in. We'll see what happens. But before we do that, I wanna tell you about something really special. Even if it's a little hard right now, that's okay. We're just gonna go over it for someone that might understand. Thanks to my friend Miss Donna who helped me with this chart, this is called the pH scale. It goes from 0 to 14. The pH scale, little p, big H, is actually called that. It's called the potential of hydrogen. Hydrogen's the big H. And what this number scale does is measure how acidic or how alkaline a solution is when it's dissolved in water. Well, that's really a lot to take in. But I want to show you something. In the middle, it's kind of a silly picture, but it's the word water. Water is at number 7. Water also is neutral. So water's in the middle. It's not really acidic, and it's not alkaline or basic. But I'm going to tell you some other things that are acidic. We know lemons, they're really sour. And tomatoes, those are both on the acid side. Now if we go the opposite end, how about soap? Or all the way on the bottom, baking soda. These are both alkaline or bases. And something tricky about this scale, it's not just 1, 2, 3. With every time you increase the number or decrease the number, it's actually by 10. And it's a scale that's very special. It's called a logarithmic scale. So it just means that each value is multiplied by 10. That's okay, that's for high school. But what we're gonna do, ladies and gentlemen, we are going to mix baking soda, which is basic, with vinegar, which is an acid. Now what happens is something really cool. It's called a chemical reaction. And you're gonna see something that you'll be able to do at home. Okay, so we're gonna put that away and get back to the experiment. So what we did here is we pre-measured the baking soda in a little cap. These are just plastic water or soda bottle caps. So on the count of 3, we're gonna pour it in all at once. Are you ready? Yeah. 1, 2, 3. There we go. Look at all those bubbles. Now the acid is working against the base, and they're fighting against each other, and what they're doing is something called neutralizing each other. The chemical reaction is producing all those bubbles, all the carbon dioxide gas. It's kind of like what's in your soda. But if you look closely, once the bubbles go away, look at the raisins. The raisins are going up and down. Some are floating at the top, and some are staying sunk at the bottom. But you could probably watch the raisins float around for another 5 or 10 more minutes. But why do they move? Why are they moving? Well, if you look really close, there's teeny tiny bubbles that are grabbing onto the raisin. And when you get enough bubbles, it's doing the same thing as this.
Whoa.
This life jacket here, if I was wearing it and I jumped in the lake, I would go down, but then I would come back up. So there's plenty of little tiny bubbles right in this life jacket that would keep me floating. Now, those bubbles are not contained in a life jacket. So when the bubbles touch the top of the air, they pop. And then when they pop, they go away. And then the raisin sinks down back to the bottom. But there were a lot of bubbles in there. So more new bubbles grabbed onto the raisin and brought it up to the top. Maybe they floated around a little bit, and when they popped, the raisin went back down. So that was pretty cool. Can you imagine if we used more? Oh boy, should we try it? Now, something I want to make sure. Before we just do any science experiment, we always need to make sure that we have permission from our parents. Because we don't want to just go rummaging around in the cabinets unless they know what we're up to. We also really don't want to make a huge mess and then have to clean it up later unless they know, again, what we're up to. So make sure you have your parents' permission. So remember this, the 1/4 cup. Who thinks we should add more?
Me, 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 me.
Okay, so what we're gonna do is we're going to add another 1/4 cup. And we're going to put in two baking sodas. We already know that singing didn't make the raisins dance, nor did shaking it or blowing on it, so we're just gonna add them in. These raisins we cut into tiny little pieces, so I'm just gonna count them as I put them in. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll try it again. Are you guys ready?
Yeah.
Here we go. 1, 2, 3. Oh boy. Woohoo! Lots of bubbles. Look at that. That's why we have the tray or pan, cookie sheet, or bathtub. That just saves us from having to clean up a lot of mess. It even sounds fun. Look at all those raisins in there. They're probably having a lot of fun. Oh, there they are. Sometimes you might even notice that these ones aren't dancing as much as the other ones were. But that's kind of cool with your science experiment, is you never know what results you're gonna get. You just have to keep trying and test something else for next time. So that's what we're doing for today. If you have any questions, please feel free to ask us on our Facebook page, Northwoods Children's Museum. Thank you.